Will you give me just a few minutes?
Sure.
I'll be right back and
Yep.
take a bio break. Thank you.
I'll be right here.
Hi, Eric.
It is.
So what type of doc do you have? Is it doc?
The IRSD.
Ah. I hadn't seen a pink dot
Yeah,
before.
well, it should be like a 15.
There's a cheat sheet for dots out by the registration.
Is there a cheat sheet for dots? I have to get my cheat sheet.
Yeah.
Okay, so
Margaret isn't here. She's the first presenter. And Aaliyah isn't here. Not that that would be critical. So maybe wait a couple minutes more. I don't know.
we'll give it a couple minutes. We don't have
Yeah.
time. We're gonna start a couple minutes late. If you want to go get beverage or something, we'll wait for you, okay? How did Babel go?
Oh, good, good. We had 2 hours and we theoretically had 65 minutes, by a moderately generous estimate. And the people spoke for about the amount of time indicated, but then there were good questions for everything. So we ended up using more like 110 minutes out of the 120. And, Alvaro was there as well as Aaliyah and other good people. And it was pretty good. Russ was chimed in with some things occasionally. Russ White, and
Is Margaret?
Margaret is scheduled to be the first speaker. So it turned out both Margaret and Bob Briscoe, I think they need to do it into area. So Bob is early and Margaret is late at into area. So Margaret is early and Bob is late in Trill.
Trill. Okay.
But she's
So after the presentation, should
Actually-
we just do a working group adoption call for Bob's stuff, or do it?
yes, I think we should start. We should issue a call for working group adoption and post it to the mailing list later tonight and run for a couple weeks, something for to adopt Bob's draft. Well, I guess of course I'm here and Lee Zhu is here. We're the second presenters.
Well, we can
If
do
you
the
go through
second
the-
presenters and go
Yeah.
to the first and wait. Just go ahead and
You want to call it to order and introduce the head
Yes.
table.
Hi, folks. This is Trill. If you're working for Trill, come toward the front so we can hear you. Otherwise, the chairs feel lonely. We are going to get started with the administrivia. Donald, if you will forward to the note well. We're calling to order the Trill Working Group. Oh, excuse me. Donald reminds me. This is Sue Harris. I'm a co-chair along with John Hudson of Trill, and you have entered into the land of the Trill Zone. And we will begin our presentations, but first let us start with our administrivia and agenda bashing. This is the note well. How many people have never seen a note well? How many people have written a note well? Margaret. Okay, please note well that anything you say is a contribution in the working group. Please read these note wells to find out what that means to you. Okay, let's go to the next one. The document review is we are progressing a lot of documents we've been working on for 2 to 3 years. Please read them. Many of you have been very active, but we're in that final push and we're creating a lot of RFCs from all the good work. So please read the documents. And this is our schedule, where we're going to do this administrivia for a few minutes. We're going to do status and milestones. And then, Margaret, are you ready for Trill over IP? Good. Then we'll do a presentation by Donald and Yi Zhao. And then the charter review, because Bob is presenting in INT, and I believe, Margaret, you have to go to INT as well afterwards. So hopefully our time is work. So is there, yes, is there any questions? Okay, then we will go to the status and the review of milestones. If you look at the RFCs, we've added RFCs. Go ahead to the next one. These are our standard RFCs. So our last 3 have been adopted. Very good work. We've got some more in process. Go ahead. They're in the editor's crew. We have Trill IETF sub-TLV. We have Trill IRB, and we have Trill tree selection. Thank you to the authors for the hard work. There is a callback from the ISG on ARP optimization, but I believe the authors are working through that quickly. And there is a Trill channel that's in working group last call, and the following have passed working group last call, which means read and review. We're making quite a lot of progress, thanks to all the authors and Donalds. And we have last call for tree centralization, replication, and resilient trees. And we have other drafts. Now, the Trill working group Yang drafts were sitting in hold because the Lime working group had not finished its work. It is in working group last call, and we anticipate these. The authors have said now they're ready to finish off based on the Lime, the Yang drafts. And our milestones that are completed are listed there. And we have overdue milestones, but as you see, we're in progress to get those submitted.
Since we're considering rechartering, it would be an appropriate time to also reset and perhaps augment the milestone list.
And I will have a chartering discussion. And I think that's it. So now Margaret will do the keying, and hopefully we'll get through everything so you can see the chartering discussion before you go to INT.
Do you like control? Or do you want me to?
Control is good.
So I'm presenting this largely because I've been working on the Trill over IP draft. Donald has been working on the group keying draft, but at this point they're very closely related, so we're just going to have one presentation on them.
Should I close the door?
Excuse me?
If I should close the door.
Oh, that might be good because there's quite a lot of noise out there. There are 2 different drafts that need to provide data security that are going through the working group at the same time. One of them is the R-Bridge channel draft. draft IETF Trill Arbor Channel 10. And one of them is the Trill over IP draft, which is at draft IETF Trill over IP 6. Okay, both of these drafts have the same need, which is that they need a way to do multi-party keying. Right now they can do point-to-point, but they can't do point-to-multi-point securely. And so Donald's come up with a way to do that, which is defined in this third draft, which I think if I go, okay, they both need group keying. And he's come up with a way to do this that would work for both of these documents. And we've already agreed in the working group to advance the channel tunnel document with the point-to-point keying defined, and say that group keying is kind of left to future work, and then publish the group keying document, and then publish how it's going to be used by the channel tunnel. And what we want to do basically is put Trill over IP in that same bucket to advance it with the point-to-point defined, work on the group keying, which may take us a little while to get right, and then document how both Trill over IP and the channel tunnel draft would use group keying to allow point-to-point, point-to-multipoint to be done securely. Right now, currently, if we did want to do a multicast messaging and we wanted to do it securely, we'd have to serialize and turn a point-to-multipoint message into a number of point-to-point messages. And the Trill over IP draft already explains how to do that, but it's inefficient. So it's not that things wouldn't work, but we'd be able to define another draft how to do it more efficiently. There's a group keying solution document that's been designed and is currently in draft East Lake Trill group keying. It's just come out as an individual draft between the last two IETFs. It securely distributes shared keys to the group members. So in the case of multicast traffic, the members in that multicast group. It provides keying for multicast and broadcast. But which group member originated the packet is not known. So there would be a group key, and you could know securely that the packet was originated by someone in that group, but you would not know who in that group originated the packet. At least you wouldn't know that securely. That could be spoofed. So this is how we're trying to solve that particular problem. If authentication of a particular group member is needed, then you need to use unicast packets. You need to use point-to-point so that you're actually authenticating who sent it. And as we said, that's less efficient, but that's already supported by the current Trill over IP draft and also by the current channel tunnel draft. So we have an idea how to move forward here, and it's a three-step process. The first step would be that we put both the channel tunnel draft and the Trill over IP draft through with the point-to-point keying, and the way to use it securely is to serialize your multicast. Send it to each point directly in a point-to-point manner. Then we write a group key distribution mechanism, which we're going to probably need a lot of help from the security area on. We've been getting help from the security area all along on these drafts, so I assume we'll be able to get it. When we've got that done, we write a draft covering how to use that group keying mechanism in both Trill over IP and the channel tunnel draft. So this is our proposed way forward, which will get us unstuck on both the channel tunnel, which I think we've already decided to move forward this way, right, Donald? And Trill over IP, which we're asking the working group to also agree to move forward this way. So this is our proposal right now that we're asking the working group to agree to. And the plan going forward shows all of these existing drafts and what new drafts we would be planning to write. So there's Trill over IP, and there's Trill channel tunnel. And those are our two deliverables, right? And right now we've got Trill over IP 06. And I think we've got Trill over channel tunnel.
It's 10 is the current version.
10 is the current version. Okay.
Yeah, which is past IETF.
Right. And that's already passed IETF last call with only the point-to-point keying and transmission in it. Okay. So what we're proposing is that we send Trill over IP version 7 to last call with only the point-to-point keying and transmission in it. And that we then write this group keying document, which or we adopt this group keying document that Donald has already written I'm assuming we like the contents of it. And then we end up publishing it as a group document eventually. And then we also write a document that explains how to do trill over IP and channel tunnel using the group keying document. And I think the way this is drawn, that would be one other document that explains how to use it for both of those capabilities. So does everybody understand what it is that we're proposing we do? This is mostly about what is in each document more than it's about the particular technical solution. But is there anybody who feels that they don't understand, has any questions about what we're proposing here? So our next steps are that we hope that if people agree, draft IETF Trill Channel Tunnel will proceed normally. It's already been through IETF last call. We'll revise and create new drafts as on the previous page, which means we'll make a new Trill over IP document that says that, you serialize now, and that point to multi-point will be defined later, very similar to what it already says in the channel tunnel document. That we then, working group last call, the Trill over IP draft, because this is, as far as we know, the only remaining issue in that draft, and we move it forward like we have channel tunnels through RFC publication. That hopefully the working group will adopt the new fairly generic group keying draft. And then I think we're kind of leaving out here, we will, and then later on, we will write the more specific draft on how channel tunnel and trill over IP will use that generic group keying draft. And we'll try to publish both of those documents. So I think really what we're looking for is feedback from the group on that plan. Does that seem okay? Any concerns particularly? We'd like to know if anyone has any concerns about it. I imagine we're going to have to put a call out to the mailing list to see if it's okay with everyone too. But that's basically where we are at this point, with a hope that we'll have a document ready for working group last call about a month after this meeting.
Yeah, the only thing I would say is that when the plan causes this group keying document, current group keying document also has some specific stuff about channel tunnel and stuff. When it's separated out in the 01 version, which is just group keying, and we do a working group adoption on that, it might also be an excellent time to ask for security review by somebody in the security area.
Yeah, we also need people to just review that document. I mean, at this point, we're not asking the working group to adopt the group keying document. As Donald said, it needs to be updated. It also just needs to be reviewed by people in this group as well, which I don't think we've gotten really any feedback on it yet at all. So, so please review that document as well as what's up here. I guess we can make a request to say, please look at it. In 4 weeks, there'll be like a cleaner version, but it would be really great if we could get some feedback on that document sometime in the next couple months, so that we can possibly update it again before the next IETF if there's feedback. So. Anybody have any questions or anything? Nope, resounding silence. I'll take resounding silence as, since they said they understood what we were proposing, I'll take that as that sounds okay to me. Okay. Since I asked for objections or discomfort and got none.
Thank you. Okay, thank you, Margaret. Actually, it turns out Margaret has to go present something else in int area. And also Bob Briscoe is gonna, on the schedule late here, is currently presumably presenting something in int area. So he'll be showing up here. So it's
far end, they're getting us work
from. The far, yes. So it's just, a little extra walking. And so we clearly need to list int area on our conflict list.
I'll get back, but it's not at all.
And SUPA is at the same time. So
yeah, SUPA is at the same time. So so let's see. So this is intended just to be an update on what's going on in the directory related drafts, and also the optimization draft, which was returned to the working group. So just going over the drafts, there's the IAF-TLV, which is actually in the RFC editor's queue. This is a data format draft. So we remember hearing about this channel tunnel draft. You can use it for lots of things, but it is also related to the directory stuff because it's used for the security of pull directory messages, requests and responses sent to and received back from a pull directory are secured using the channel tunnel draft. The main directory assistance mechanisms, one provides sort of the big mechanism. It supports push directories and pull directories hosted on R bridges, whereas pull directories hosted on an end station, and it lets other R bridges extract stuff from those directories. And I have a diagram showing this and the next slide. And then there is an extension draft, which is going to extend the access to the directory to end stations. And I'll explain in a sec why we want to do that. So there's a diagram showing what it can do. So there's a push directory client over here, and it can send requests. You can either have everything pushed to it, or it can send requests to it to a pull directory. And an R bridge could be a push directory or a pull directory or both, or whatever it wants. And it also defines how to send pull requests through a proxy. It defines what the proxy does. This client doesn't know it's a proxy. It thinks the pull directory is here, but it can actually be on an end station. And there's a mapping that occurs here because it needs to send some more information. And here's just an ordinary end station, just to show for no particularly good reason. This goes here. And so we'll see in a sec, if this R bridge wanted to do ARP optimization, it might base that on information that it had gotten from the directory. So what does this extensions draft do? Well, the extensions draft allows an end station to actually send pull or requests or to get stuff pushed to it from a client proxy. So the client proxy looks like just like a regular R bridge. So if this end station sends a pull request, it can see this client proxy here. It gets forwarded to the pull directory here, or possibly even through this to a pull directory on an end station. And if stuff's being pushed, stuff's being pushed to here, then this end station could request that the direct stuff be pushed out to it. So why would an end station want all this directory stuff? Well, okay, here's a page on the client drafts, essentially. There's the ARP optimization draft, which indeed wants directory information or local information about the correspondence between IP and MAC and things like that in order to be able to optimize, respond locally to ARPs or neighbor discovery or things like that. And there's two drafts about specialized end stations. These are special kinds of end stations. There's the directory assisted encap, and this is an end station which does the trill encapsulation itself and sends the encapsulated packet to the edge R bridge and the edge R, but at the far end, anything going out to that end station is actually decapsulated at the edge R bridge. So it does encapsulation, but it doesn't do decapsulation. And there's also a draft on smart end nodes, which do both encapsulation and decapsulation, and can actually do address learning and things like that at the end station. So those would be potential clients at end stations. Most end stations currently don't obviously know about directory services. They'd have to add something to the end station for it to be able to use those services. So that's so here's what's kind of going on. We have the data structure is in the RFC editor's queue. Channel tunnel is past IETF last call, and this needs a little bit of minor changes to get through the IESG. Directory assist mechanisms, Lee Yuzhu is going to talk about that in a second. It's been sent back to the working group. It has gone through a working group last call. And the ARP-ND optimization, sorry, that's the ARP-ND optimization draft up here. This is the directory assistance that has been through last call. It needs some review comments resolved, sorry. And this is the directory extensions. This is a dependency draft. So like smart end nodes would have to use directory extensions because it wants to get to the directory from an end station. And here's the main directory mechanisms which use this data format and use this security mechanism. Okay, so I don't know. You want to talk about this? Yeah. Okay, so this is why the ARP-ND was sent back to the working group and what we need to do.
Wait.
which one is that?
The left and right arrows move the slide forward, and there's a, yeah, that's it.
Yeah. So this ARP and ND optimization draft, actually, we received some deep questions. So it's returned to the working group. And is it working?
Yeah.
Okay, so we received 3 discussers with the listed points here. The first one is regarding the how to age out the learned address by the edge operators. We didn't touch it. So actually there are various possibilities. So we are going to cover it in the next revision. For example, the very traditional timeout is going to be can be used, or periodically the local station can send the ARP and D pins. So we are going to touch this part in the next revision. And there are some options in current revision section 3.2. There are 5 options. Currently, we are leave for the implementers to use any of them, but the suggestion is we should give some guidance, especially actually when the security ND is used, some of the options might not be applicable. So that's why the guidance would be required. And the third point is the source address of the responses for the ARP should be synthesized by the edge operators. This part we are going to touch it in the next revision as well. Okay, here is a continued. Okay, for this one, I've kind of covered already. For the send, we are going to clearly specify what to do in case of the security ND, since some of the options should be ruled out. The last one is there are some questionable keywords. Okay, it's going to be fixed. So here's the plan. We have already respond one of the discussed out of 3. And what we are going to do is to produce and post an updated draft to incorporating all the changes agreed by AD in who had posted the discuss. We have reached 2 out of 3, so there is 1 left. We are going to reach and get the agreement. After the things here listed to be solved out, we are going to run another working group last call to request the publication. That's the plan. Any comments or questions regarding this? I don't think so.
Okay.
Thank you.
Thank you.
Shall I run the?
Well, I can. I don't know if
can
there's
run
any
the chart
comments.
stuff from here since it has animation.
Well, I can run. I'm running the PowerPoints from here, actually.
Okay, can you run PowerPoint? Okay.
Sure. I have Office on my Mac.
Okay. So, this presentation comes from John Hudson, but John's not with us today except on the phone. So thank you, John. He always likes animation, so I have to get up. So in April, we brought up the subject for charter resolution. Now we're presenting draft changes. The current charter, I think you can see that we've gone through all these items. And that would be good to get blue sheets. We've gone through standardizing OEM, active, multi-destination, frame reduction directory, trill over pseudowire and over P, multi-level, multi-topology. I am really impressed with our solutions in that. That's just the chair since I'm not the author on all of those. The reduced control plane, the security analysis, and interoperability. This is the status. We've gotten RFCs. We have drafts in most of these cases, We've gotten almost all of our multi-level topology. We've got pending drafts in the intercampus reduced control plane, and we've got pendency drafts based on the security analysis. We just went through all of those drafts where we have the dependency on the key. And we moved the stuff on the interoperability to the wiki. Here are a few things we think are useful for the working group. The real thing that we're looking for is, just as many things are moving toward SDN or controller, we'd like to make sure that Trill, like many of the forwarding protocols, has better SDN support. We want to increase our transparency, which will reduce coupling, and we want to add some small content. Now, one of the interesting, so you can see the proposed changes here. I'm going to pause here in case you want to look at the charter. Okay, here's another chance. Shall I go back and let me go a little slower? Rather than read words, for those of you who are in the back, come up in the front and ask us questions. I can read them, but usually I trip over a word.
Yeah, stuff here that's crossed out is going away, and stuff that's underlined is new text added. So like the previous slide is all crossed out texts. So it's stuff we've completed. This is the first slide with any stuff that remains.
Sure, Olea Atlas. So I just have a question with the traffic engineering, because traffic engineering can be sizable. And the question here is, who needs it? What's the drive and motivation? And there's a lot of really cool technology in Trill, but there's also already a lot of complexity. And I'm interested in understanding what the requirements and basically where the operational desire to use it is, what the applicability is. And I mean, you produce a lot of really good documents, but it's a lot of documents and they have to be implemented, deployment, learning. I'm a little concerned about continuing to add more and more functionality that can be quite large.
Okay, one of the things that, it's a really good question, and we need to be concerned. One of the questions I had, and one of the reasons that we got into traffic engineering, is Bob's ECN draft and his comments on needing it. I don't know if the ECN stuff, the little twitch question.
Bob has excellent knowledge of ECN and related spaces, but I'm not sure that his understanding of Trill operators and deployments is very large.
Okay. Well, that's a point that we'll probably should do some more discussion on list and off list then. Okay. That's good feedback. Let us dig a little into that. That's an interesting point. I'll just leave that publicly where we have it. Perhaps you and I and Donald can have a heart-to-heart talk afterwards. Yeah. Transparent connections, Donald. Ali is looking for links to.
Well, that's basically if you want to provide a carrier service which is more independent of the attached networks. Trill, as originally written, was essentially purely a customer level protocol and all ran at the same level. But there are deployments and implementations that are being used in more of a service provider mode. And in fact, at least one implementation which is called Trill and uses exactly the Trill data format, uses a slightly different control format, and has actually always been more transparent. And so the example given here is that currently Trill was specified very carefully to minimize spanning tree and block BPDUs at the edge and so on. Whereas if you want to just let stuff flow through and have the Trill be more of a provider pipe or whatever, then you want to have a mode which is less coupled. And I think there are implementations that do that, but there's no way standardized in the spec for doing it.
And the operator deployment in Poland and some of the other places, my understanding is that they were sort of looking for something like that. Is that?
Yeah, I can't say specifically where the one I know about is, but it still is used in several internet exchanges, for example, and that's an example of a case where, depending, you might want to be more as transparent as you could.
Okay.
Several internet exchanges in Eastern Europe, particularly in Europe.
Sure, that makes good sense.
Okay. I'm trying, since you're asking specifics, we're trying to give you deployment specifics.
Since I told you what the mode of notation was as to whether stuff was new text or not, I should probably make that be sure that that's true. So there's one point here which actually should be underlined.
Okay.
Sorry.
Okay. And again, just to help our ID, my understanding of 6 and the deployment characteristics is number 6, where you reduce control plane and action and error isolation, was to deal with some issues as well in deployment. That's what Lee is asking, is deployment questions. Right. Yeah.
Well, I guess what I'm saying is you've got a lot of good technology, but a lot of complicated, and at some point we need to pause and say, how's it going with the industry? What are they using? Can we start moving to supporting operational deployment concerns and issues, as opposed to,
that's why
6 is
the chair's discussion have headed toward not adding features, but only adding features that are for deployments. So that's some of the stuff have been given to the chairs in confidence, but that's why I'm trying to have this little side conversation.
Sure. I guess question for number 5 is, when you're talking about payload types, such as IP, are you envisioning that being like a next protocol field type of thing, or?
No, there exist bits in the header,
okay,
which were originally, they're critical bits now, and are treated as such by existing silicon. And so you could use a field in there for payload type, and it's basically just for not including unnecessary fields. Like if it's IP, you don't need the MAC addresses and stuff like that. And it can be done safely because existing merchant silicon will trap such packets. And if you are about to forward to a trill switch which doesn't support that feature, then you can in fact expand the packet and make it compatible. So it can be that, that's the main goal.
okay.
Would you classify the ECN stuff from Bob under this category?
ECN stuff is really, it's basically anti-buffer bloat at all kinds of levels. I don't know. I mean, it certainly exist data center deployments of
It's okay. I don't need to be convinced of the necessity of ECN.
Okay.
I did QoS in my PhD. It's fine.
Okay.
I understand we need ECN.
I mean, this is not confidential. I think Huawei has deployments of like 3,000 nodes running Trill, so internally. So.
Yeah, name change because life has been crazy with people misconceiving, but that's a Minus trivia moment. Okay, so I think we need a discussion with the AD on the one point on TE. I think the rest of them, Donald, did we hear anything new? I don't know that John's got, is John got feedback in there on, I didn't get the Jabber up and functioning, so.
Well, he's on the Meet Echo, so he
John,
could speak if he wanted. I don't know.
Can you speak on?
He could if he
Echo?
wants, but it doesn't. I'm not sure. Yeah, maybe not. Okay.
I'm not seeing it. Well, John, if you can send us email if we've missed anything. Questions, Yuzhao, Mingli, do you have anything from needs from deployments? Anyone else? Okay, I mean, that's what we are trying to focus is what do we need for actual deployments?
So one thing, this is brainstormed on the fly, so you could take it for all it's worth. But one thing that might be interesting to think about is something along, I guess something like a deployment experience or applicability that, or profile, or there's an awful lot of different options and pieces, and it might be really nice to have sort of a map of this is a piece of it that worked well together to solve particular applicability.
Yeah, there are
Maybe
there's
those exist already, but
there's a spectrum of things which might be because although Trill tries to be zero configuration, there are things you can tweak here and there, and there's also things people have encountered which blindly following the letter of the spec turns out not necessarily quite be the right thing. In particular, cases where you might be if you have parallel links of really radically different bandwidth, you know, that you really better to ignore the ones that are like insignificant because, you know, timing and et cetera. And these are maybe fairly obvious, but, you know, a thing on implementation deployment of Trill, you know, actually more like configuration deployment would be.
yes,
fun.
I wasn't necessarily speaking about so much the deployment
Yeah.
as the,
Sure.
I have to talk with my hands, you see, the broad feature set.
Yeah.
Right. So there are many drafts where you could say you could do it this way or that way, and it's a lot to read. So I think having something that, I mean, we want to encourage deployment, and one of the ways of doing that is to sort of articulate sets of functionality that are working to solve particular problems. Not saying it needs, but just to think
Maybe
about.
useful. We had put, it might be good to go with along with another focus on the implementation reports on the wiki.
Yes. Yeah, the ECN stuff is basically essentially they're tweaking some bits in the header essentially. So I don't know, you know, but it's not explicitly called out as a work item certainly, but it's so I think it's okay.
Put it in there, make the transport ADs happy.
Okay, we can put it in there.
Yes, we now know what we have. We have one item to check on and a couple of things to,
I think all the ADs should be happy, including the transport AD.
transport ADs must be happy. Spencer and Mirta need to be happy. Okay, we are on a pause waiting for Bob to come out of the hint here.
Actually, I'm listed on that presentation
Okay,
also, so I
please go
guess,
ahead.
you know, we have like 18 minutes left in this session, and we reduced our request to 1 hour because there were so many work items for this session requests for this IETF meeting. People were generally asked to try to reduce their requests. So, but
Do you want to
I
try?
could give the ECA. I'm sure I can't give it as well as Bob, but yeah, you have a go ahead.
Yeah, for the last item, I think it's item 6
Go
in
back.
the charter.
Charter.
We just did the charter, and it worked.
Yeah,
Yes.
the charter.
So there's some particular slide or
Yeah, actually, it says with improved error isolation. I think there is a new document uploaded regarding to collect the statistic error data or
Okay.
non-error data. So probably it's we can put the improved error isolation and the statistics collection
Okay.
into the item
Okay.
6.
That would be good. Most of the Trill Yang models, well, they have both OEM and regular configuration, but I didn't check. I need to go back after they finish the Lime stuff to even look at the OEM models for error statistics because they were first focused on something else. So that's a good comment. Okay.
so I would say this is the technical stuff here is really mostly from Bob. So I sort of supplied the trillish part of it, but Susie isn't here. I have like 15 minutes left. So what is ECN? Explicit Congestion Notification. Well, I don't know how many people are aware of it, but basically it provides where sort of an indication going down the stack. This is higher level applications, and layer 4, layer 3 is the IP, layer 2 down here. Indication that it's ECN compatible transport? Yeah, capable. ECN capable transport is indication on the way down, and congestion experienced on the way up. So the idea is that the far end knows whether some data it received ran into a congested thing along the way. Of course, if the congestion was severe enough, the data won't ever get through at all. But usually you don't have, you know, a sudden blockage. If nothing is getting through, then you no longer have adjacency, and other mechanisms will work. So it's just congested. It presumably just some of it will get through, and that can all be marked. Yep. Okay. So the idea is that you can mark in IP these days whether it's ECN compatible, and you can mark whether it's experienced congestion. So 0, there's some bits which when there's 0, this sort of the default means it's not ECN compatible. And if there's 1001 means it is ECN capable, and if 11 means it experienced congestion. So normally IP does flow control based on the loss of packets, but if you've lost the packet, then the data didn't get through, and you've kind of not in as good a shape. You really prefer for the data to get through, but to still learn that there was congestion, so you can perhaps throttle back the rate you're sending. So the idea is to do this in Trill using the extension flags word, yep, in the header.
Sorry. Oh yeah, it was no hats this time, but
sure.
Just a little confused. Could you go back?
I could.
Thank you. So the whole point of having ECN is to be a message to the host that congestion was experienced. And if you get the signal, you want to, I mean, I guess what I'm poking at is why, what is the reasoning? And I realize you're not Bob, so you may not have the full answer, for not propagating upward to the IP header, because the IP inner header is what's going to be received by the host to get the congestion signal to back off.
Well, it does get propagated to the IP header if it's IP traffic. There's a later slide which shows the tunnel structure.
Awesome, thank you.
Only like 1 or 2 slides later. So, sorry, maybe I'm just probably not doing a very good job. I didn't expect to present this. I don't know. Anyway, so yeah, so there's this optional flags word which has a few bits defined in it currently. Like if you need a bigger hop count, you can put it there, or some alert bits. So the idea is to put this, the current sort of ECN field like you have in IP fits in a couple bits over here, and including a value which is the non-critical congestion experienced, which is slightly renamed for the Trill application. And there's also a bit over here. So in this flags word, there are some bits that are predefined to be critical and some bits that are predefined to be non-critical. And we can have a critical congestion experience flag over here. So what happens is when you have traffic from the end station, the ingress arbage copies the ECN field from an IP header, or if it happens to understand some other protocol, into the Trill header. This is then you go through some transit links, and some of these transit links might not actually be ECN aware, but that's okay. And if you get one where it is, and there's congestion experience, namely the buffer queues are too big or whatever, it marks it using the critical flag, and it doesn't actually bother to check whether the transport is ECN capable or not. So basically, the ingress should do this copying, and the transit things just need to, if they experience congestion, they set this bit long. And if that word isn't there, they may have to add the word in because that's an optional word on the header. So when you get to the egress, then things get a little more complex. So if let's assume this is some other kind of traffic, since you've marked a critical bit, if the egress doesn't understand ECN at all, it will throw it away. So it'll get discarded. Only if the egress bridge understands ECN will it do more complicated manipulation on these bits and possibly insert a marked thing into the IP header, which it's decapsulating.
Early Atlas, again, no hats, but so when I've seen ECN implemented in routers, it's generally that you're setting, it's as part of the, it's part of the egress queuing or virtual queuing, depending on what kind of game you play.
Sure.
But the point is you set the bit as it's going into the queues, which is frequently well after you've done any of your header manipulation. So the idea that you might have to add a...
I would say if that's in that case, such a router should perhaps add it in all cases. I mean...
So I would request that people who have hardware implementations take a serious look at this, because if what you're saying is as long as you do ECN, you need to put the word in, that's fine, but they need to, that comes with its own cost, and normally ECN doesn't really come with a heavy cost to implement. But the idea that you're going to have the hardware, I am not as familiar with switches as I am with routers, you know, mea culpa, but
not that much difference.
But what I have seen of switches is pretty darn similar, particularly at the QoS level. And I think that what you are describing would be, if you're optionally adding it when you see, if you expect to optionally add it when you see congestion, I don't think there's going to be a lot of uptake. So really, really, really talk to folks who are doing the hardware implementation.
Okay, sure, it needs to be looked at more. I would say that while all forms of compatibility are really good, and background compatibility, in the real world, if it's in a data center or something, very likely all these things will be at the same capability level. So if some support, it's implausible that you have randomly scattered ones that support ECN and ones that don't. And in which case, the ingress will always add the word as part of the ingress in cap.
Elia, you of course have more familiarity with how Trill is being deployed out there than I'm afraid I do. But
I'd also like to say that a thing frequently referred to as a Trill switch is a real layer 3 router. I mean, it logically it throws away the layer 2 header, looks at the next nickname, and adds a new layer 2 header. So it's really a router. It just routes on nicknames instead of on IP addresses.
Sure.
Or something like that.
What I'm talking about is the expecting to do header manipulation at the QoS about to shove it out the door stage. Yeah. That's the part that has to be twitching.
That's a good point. I mean, excellent point. But I think what any intuition you have about routers seems like it would be applicable, at least for this sort of thing. So
it was applicable on the Ethernet switch I've been familiar with.
Hi, Bob. I was just talking about tunnels, and yeah. Do you want to
continue on.
Join, or want me to keep going, or?
Oh, join on.
Okay. So these are the rules at egress, which are this is the classic rules, and where you have a mark in the outer header, which would be the Trill header, and a marking in the inner header, which would be the IP header, most typically, and how you combine those at the egress. And this is the Trill case, where you have 3 bits you're combining. So it's slightly different. So what are the changes? There's a draft 01 has just been posted. So there were several different options presented last time, and we decided to change from option 2 to 3, which basically means changing from classic ECN to this bit technique to use a critical bit, because that gets you the benefits of ECN to a considerable extent without having to assure that the egress supports ECN. I mean, actually, when the egress doesn't support ECN, you don't really quite get the benefits of ECN, but at least you get the traffic discarded. So you get the IP flow control. Renamed a couple fields, as indicated earlier. And there's now a section in the draft on support for ECN variants, including precongestion notification and L4S, which had a successful boss on Tuesday. And that's, I don't know if I remember the full expansion. I don't know if it's on the next, but it's right here. Low latency, low loss, scalable throughput. Otherwise, it's similar to data center TCP kind of stuff. And there are drafts by Bob, who's now here. And the idea is that you want to discard with an appropriate probability. And if you do things right, which this is the classic queue, and this is the what an L4S queue does, you can get very low latency with relatively low loss and high throughput. So this is not required or anything with Trill, but the markings that are being done to support that. So if the egress supports ECN and does these manipulations and bit combinations indicated here, you end up essentially with L4S support without actually having to have any L4S logic at the egress. So people should review the draft. And I guess I was checking with Sue, okay, want to try to have a working group adoption call issued effectively at this point. So people should, well, for a couple week adoption call, and people should comment on the list, and hopefully after reviewing the document.
Was there any discussion?
No,
Did
but
you want to
any
recap anything?
points or
Bob
questions?
from
Yeah,
the
and
previous-
you can ask deeper questions than I could answer if Bob's here.
Or we can adjourn to a small discussion that's not monitored by the working group. It's up to you, but this draft.
Yeah, so anyway, it's only like 2-3 minutes to the end of the session anyway. So we got stuff a little packed in this time. But if nobody has questions or comments, I guess that's,
Okay, well, thank you very much. Thank you for active participation in working on this. Okay, I've got notes. I'll upload them this evening. I've already taken the minutes. So we're good to go.
blue sheets, thank you.
And I can take those to the,
There isn't anybody at the registration desk. So,
other, I can take it to Carl.
Hi, it's been a while. It's
hi.
yeah, it's different. Yeah. Good, good. Yeah. So I haven't been to the IETF for a long time.
Yeah.
So that was just
Okay.
coming back after a long time. So I'm just trying to
Yeah.
comparing of things and stuff. So,
Sure.
yeah, nice to see you again. Thanks for the letter.
How are you doing
Yeah,
today?
well,
I have 15 minutes before I'm supposed to meet someone with family.
Actually, I sent the authors, with one question in the email.
Yes.
And I don't know if I'm kind of started to catch up with the authors documents, and I kind of moving the architecture. So I think I'm very missing something.